Hello everybody, welcome into another lesson. So today we are going to talk about the law of cosines. So yesterday we talked about the law of sines, in which you could use it to solve triangles of the angle side or angle side angle variety where you only had one triangle for those, or you could have side side angle where you could have one triangle, no triangle, or two triangles. Well, today we're going to do the law of cosines, and we can use this to solve side angle side and side triangles, which we couldn't use the law of sines for. But the good news is, in each of these cases, you're only going to get one triangle, because the cosine is positive in the first quadrant, but it's not positive again until the fourth quadrant. Well, a fourth quadrant angle would put you well over 180 degrees, so we only have to worry about the first quadrant for the law of cosines. So this comes in one of three variations depending upon what you're given for your triangle. You could have a squared equals b squared plus c squared minus 2bc cosine of angle A. You could have b squared equals a squared plus c squared minus 2ac cosine of b, or you could have c squared equals a squared plus b squared minus 2abc cosine of angle C. And you're probably looking at that last formula thinking that looks very similar to Pythagorean Theorem. Well, in fact, Pythagorean Theorem is derived from the law of cosines. Because if your angle C is 90 degrees, well, what's the cosine of 90? That's 0, right? So that eliminates this whole term. You would just be left with c squared equals a squared plus b squared, which is Pythagorean Theorem. So yes, you would be correct in your assessment that it does look like Pythagorean Theorem, because it is derived from the law of cosines. So let's set up a triangle here. Let's do some examples of this. Alright, now when you set up your angles, it doesn't matter what order you set up your angles in, but the opposite side should always have the same name as your angle. So side A should be opposite angle A, side B should be opposite angle B, side C should be opposite angle C. Just like in the law of sines, it's the same with the law of cosines. A lot of people make mistakes because they mislabeled their sides. They just went around the triangle in alphabetical order as opposed to properly labeling their sides. That can make all the difference. So what are we given for the first example? We are given that angle B is 20 degrees. We are given that side A is 120, and then we're given that side C is 100. So what have we been given? Well, first we know this is a side angle side case. Alright, so there's definitely going to be one triangle. Now, we have angle B, but we don't know side B. So since we need to solve for side B, this is going to take the form of b squared equals a squared plus c squared. So our a is 120 squared plus that c squared of 100 squared minus 2 times our a of 120 times our c of 100 times the cosine of that 20 degrees. Alright, so there's our full setup. Now let's simplify this a little bit further. Let's figure out what the heck 120 squared is and 100 squared. Why do I have 100 to the 0? That don't make any sense. I think I meant to write degrees on accident. We're definitely not at degrees yet. Alright, what the heck is 120 squared? 14,400, so that's going to be 14,400 plus, now we have to deal with the 100 squared. That's 10,000. Now, let's go ahead and figure out 2 times 120 times 100, at least. That'd be minus 24,000 times the cosine of 20 degrees. So this would simplify into 24,400 minus 24,000 times the cosine of 20 degrees. So let's see, b squared, let's see what we get. You get approximately equal to 1,847.38, which now we can find side B. We're just going to take the square root approximation of that, round it to 2 decimal places. You get approximately 42.98. So side B would be about 42.98. So now we know side B. We still have to find angles A and C. Well, that won't be too terrible. So we got side B. Now, let's see. We can also use this law of cosines to find the angles. So let's write that 42.98 up here. I'm going to erase this, and if you need to see it again, rewind the video because we got to solve for the other angles. So take your pick. Let's find angle A. So that means we need to take that A squared of 120 squared, set that equal to our B squared, which would be 42.98 squared, plus our C squared, which would be 100 squared, minus 2 times our B of 42.98 times our C of 100 times the cosine of angle A. So you see, in the end, you're going to end up actually having an inverse cosine. So we know 120 squared was 14,400. Now let's figure out what the heck is 42.98 squared. That's about 1,847.2804, which I'm going to keep all the decimals there for now. Then we have that 100 squared, which would be plus another 10,000. Then we have to figure out that 2 times 42.98 times 100, which would give you 8,596, so minus 8,596 times the cosine of A. So let's see, this is going to simplify into 14,400 equals 11,847.2804 minus 8,596 cosine of A. So let's see here. 14,400 minus 11,847.2804 gives you 2,552.7196 equal to negative 8,596 cosine of A. So then, of course, your cosine of A would equal negative 2,552.7196 all over 8,596. And then, of course, A is just the inverse cosine of all that. We can get an approximation. Which would give you about 107.28 degrees. So you come up with angle A is going to be about 107.28 degrees, which still works in the second quadrant. You add that to 20, you're still well under 180. You just don't want to get a third quadrant angle, which you wouldn't because your domain's only the first and second quadrant of the cosine inverse. And then we could figure out angle C just by finding the difference between what's there. So angle C would be approximately equal to 180 degrees minus that 107.28 minus that 20, which means angle C so let's do this. 180 minus 107.28 minus another 20. No, I didn't want plus 20. I wanted minus 20. Give you about 52.72 degrees. So angle C would be about 52.72 degrees. So keep in mind when you're doing these, they may not match your answer key in the back of your textbook exactly, but you should be in the ballpark. You should roughly be in the ballpark here. So I mean, none of this is really exact. They're all decimal approximations anyway. As long as you're roughly in the ballpark of this, you know you did the process right. So you get side B being 42.98. You get angle A being approximately 107.28. You get angle C being approximately 52.72 degrees. Now, had you gone with angle C first and then solved for angle A, you might have got something slightly different, but you should still be roughly in that ballpark. So yes, these are all based on approximations. I'm going to set up another one here. Alright, here's side A, here's side B, here's side C. Let's see what we're given this time. So angle C is 95 degrees. Side A has a length of 10. Side B has a length of 12. Alright, so we have definitely another side angle side triangle, right? Okay, so we know angle C, we know sides A and B, but we don't know what side C is. So we want to set this up for C. So this would be C squared equals your A squared, which is 10 squared, plus your B squared, which is your 12 squared, minus 2 times your A of 10 times your c of 12 times the cosine of 95 degrees. So, of course, this would simplify into 100 plus 144 minus 240 times the cosine of 95 degrees, which would become 244 minus 240 times the cosine of 95 degrees. So then we can find c. If we just do this and take the square root of the result, we can get side c. Let's see. No, that's not what I wanted. Then I'm going to take about the square root of that answer. So you get approximately 16.28. Once you simplify all this and take the square root of the result, you get side C is approximately 16.28. Okay. Now, we need to pick on another angle. We need to pick at least one of the angles to solve for, and then we can just subtract that from 180 to find the last angle. So, let's pick good old angle A again. So we're going to solve for angle A, so that means our A squared, which is 10 squared, is going to equal our B squared, which is 12 squared, plus our C squared, which would be that 16.28 squared, minus 2 times that B, which was 12, times that C, which was 16.28, times the cosine of A. Alright, so that means 100 equals 144 plus, let's see what the heck we're getting into here. For that 16.28 squared, it's not going to be nice, I can tell you that. 265.0384 minus whatever that mess is. $390.72 times the cosine of A. And then we are going to, of course, simplify this a little bit more. That means 100 would equal whatever this mess is. 144 plus 265.0384 gives you 409.0384 minus 390.72 cosine of A, which then means that negative 390.72 cosine of A would equal negative 309.0384. So then the cosine of A would equal 309.0384 all over 390.72. So now A is just the cosine inverse of all that. So let's see about what we get. Get about 37.73. So you get angle A is approximately 37.73 degrees. Now we know C and A both, we can solve for angle B. So the measure of angle B is going to equal, of course, 180 degrees minus 95 degrees minus another 37.73 degrees. Gosh. So then we'll come up with an approximate for angle B. You get about 47.27. So angle B would be approximately equal to 47.27 degrees. And again, these are all ballpark estimates. They're not exact because it's kind of impossible to get it exactly, but get a new marker. But as long as you're in the ballpark, you know you got it right. All right, what do we got here? Side A, side B. All right, let's see what we're given this time. So we have side A is 25. What else do we have? We have side B is 11. And then we have side C is 24. All right, so we have our first side, which is still only going to be one triangle, but this is different. If you have a side, so we don't know any of the angles, not whatsoever, take your pick for your first angle. Just go ahead, take your pick. I mean, you got nothing to lose. I just go in alphabetical order, start with A. So that means we need to do the side A squared, so that would be 25 squared would equal my B squared of 11 squared plus my 24 squared, which is C squared, minus that 2 times my B of 11 times my C of 24 times the cosine of A. All right, so we know 25 squared is 625. Now, 11 squared, that's 121. I believe 24 squared is 576, but let me double check that. I certainly don't wish to get this wrong. Yep, it is 576, just as I thought. Minus that 2 times 11 times 24 times the cosine of A. So 2 times 11 times 24, so that's minus 528 cosine of A. So then 625 is going to equal 697 minus 528 times the cosine of A, which then means you would get negative 528 times the cosine of A. is going to equal 625 minus 697. Let's figure out what the heck that is. That's negative 72. So that means the cosine of A is going to then equal 72 over 528. And then A, of course, would equal the cosine inverse of that, which will be a ballpark approximation. It would be about 82.16. So angle A is approximately going to be equal to 82.16 degrees. So let's put that here, 82.16. Now we know one of the angles, but we need to find the second angle. We need to find at least one other before we try to solve for the third angle. And again, your values may differ slightly, only slightly, depending upon which angle you started with. I just go in alphabetical order. That's just simplest to me. But I'm going to vote we go for angle B. And if you need to see how I worked it out, please feel free to rewind the video. But we want to find angle B, so that means we need to set up our side of B squared, which is 11 squared, equals my A squared of 25 squared, plus my, so we have B squared equals A squared plus C squared, which would be 24 squared, minus 2 times my B of 11 times my, times my A of 25 times my C of 24 times the cosine of B. All right. Equals A, C. Yes, okay, good. I'm good. All right, so let's see. 11 squared, that's 121. That's going to equal 625 plus 576 minus whatever this mess is. It'd be 1200, so minus 1200 times the cosine of B. So that means 121 is going to equal, let's simplify that 625 and 576 a bit. Wow, so 121 equals 1201 minus 1200 times the cosine of B. So that means now that negative 1200 times the cosine of B is going to equal, let's take 121 minus 1201. That would equal negative 1080. So the cosine of B would equal 1080 over 1200. Which, of course, B is just the inverse cosine of all that. We can get another decimal approximation. You would get about 25.84. So B is approximately equal to 25.84. Now we can just pick on angle C, but all we have to do for that is just take 180 from what we have. So that means the measure of angle C equals 180 minus 82.16 minus 25.84, which, did I say B? I meant angle C. I meant to say C. We already got angle B. So C, we will get an approximate result. $180 minus 82.16 minus 25.8. No, not plus. You get approximately 72 degrees. So that gives you that angle C would be approximately 72 degrees. So we finally solved for our missing angles, and again, these are all ballpark estimates, not exact. It's pretty much impossible to get it exact since the decimals are non-terminating and non-repeating. So keep that in mind. And let's do one more of the side, side, side case. Then we'll be done with the lesson. But I wanted to do like 2 of each. Alright, what do we got? Smaller numbers this time. A is 2. B is 4. C is 5. Alright. So, you have 3 sides. This is definitely a side, side, side case, which there's only one triangle for. So, take your pick of which angle you want to start with. I'm going to say angle A. So we have our A squared, which is 2 squared. That's going to equal our B squared of 4 squared, plus our C squared of 5 squared, minus 2 times our B of 4 times our C of 5, times the cosine of A. Alright, so that means 4 equals 16 plus 25 minus 40 times the cosine of A. So that means 4 is going to equal 41 minus 40 times the cosine of A. So that means negative 40 times the cosine of A is going to equal negative 37. So the cosine of A equals 37 over 40. And of course, A is just the inverse cosine of that. And again, this is going to be a ballpark. It's not going to be exact. So let's see. 37/40ths. Now take the cosine inverse of that. You get approximately 22.33 degrees. So A has an approximate value of 22.33 degrees. Let's put that in for A. Now, we'll go in alphabetical order. Let's find angle B. We have to do this at least one more time in order to be able to solve for the third angle. So let's go for angle B. So that means we'll take our side B squared, which is 4 squared, equals our A squared, which is 2 squared, plus our C squared, which is 5 squared, minus 2 times that A of 2 times that C of 5 times the cosine of B. So this means 16 is going to equal 4 plus 25 minus 20 times the cosine of B. So that means 16 is going to then equal 29 minus 20 times the cosine of B. So that means negative 20 times the cosine of B equals negative 13. So the cosine of B would equal 13/20ths. So then B, of course, is the cosine inverse of both sides. And again, this will be another ballpark estimate. It's not going to be an exact. you get approximately 49.46. So you get that B is approximately 49.46 degrees. So we know A, we know B, we can find angle C relatively easy then. That means the measure of angle C is just going to equal 180 degrees minus that 22.33 degrees minus that 49.46 degrees. So that means we'll get an approximation for C. So you'll have 180 minus 22.33 minus 49.46. You get about 108.21. So you get that angle C is going to be approximately 108.21 degrees. So that's it for the law of cosines. The next lesson we're going to talk about another method for finding the area of a triangle called Heron's formula, which is actually pretty simple to use. And you can also, just like with the law of sines, it doesn't have to be a right triangle for you to be able to use this formula. So it's pretty nice. So I hope everyone has a great day. Take care.